Hello dear students, welcome back to Ezee Notes. Today we'll complete the chapter 2 by studying part C of this chapter, that is conservation of energy. So we'll see what is conservation of energy. You all might have learned the law of conservation of energy, like energy can neither be created nor be destroyed but can be converted from one form to other form. Like this is the ground, let us assume h height above. If I take this object, so there will be an energy stored in this object. Which is the energy? Potential energy. As soon as I leave this object, what happens? There will be some different energy generated while touching the ground. Which energy is that? That is kinetic energy due to motion, right? So one energy is getting converted to other energy, but the total energy will always remain constant. The total energy of an isolated system always remains conserved. So we can say that energy can neither be created nor be destroyed, but can be converted from one form to another form. So let us see a mathematical form of this theoretical verification. Like kinetic energy plus potential energy is constant for freely falling body. So this is a freely falling body of mass m, which is h height above the ground. This is the ground. Okay. So here there is a point A from where we are dropping this object. It means that velocity at A is 0. Okay. Now x distance below, let us assume there is a point B. Lastly, this will be h minus x, right? There is a point C. That is nothing but at ground we are taking a point C. Okay. Now we can say that at A kinetic energy is 0, right? Because speed is 0, half mv square. So v is 0, so kinetic energy will also be 0. Potential energy at A will not be equal to 0. At B, there is some height from the ground, so potential energy at B will not be equal to 0. And while traveling from here to here, it will gain some speed. So kinetic energy at B will also not equal to 0. But at point C, there is no height from the ground. So potential energy at point C will be 0, but kinetic energy at point C will not be 0. Okay, you need to remember this. So one by one, we will solve the total energies at point A, point B, and point C. Okay. So total energy at A. Total energy at point A. Okay. So total energy at A will be equal to kinetic energy at A plus potential energy at A. Kinetic energy at A is 0. Right? So total energy at A will be equal to mg into height h. That is nothing but potential energy, mg into height from the ground, mgh. So this is the total energy at point A. Now we'll talk about potential total energy at point B. Let's see total energy at B. So total energy at B will be equal to kinetic energy at B plus potential energy at B. Total energy at B will be equal to half mvb square plus potential energy at B will be mg into this distance h minus x. Mg into h minus x. Okay. So we'll find velocity at point B. Let us consider the final point v square minus u square is equal to 2as, this formula equation of motion. Final point let us consider as B. So it will be vb square minus initial point let it be A. So va square is equal to 2g into height. Distance from A to B is x. 2g into x. So va is 0. Therefore, vb square can be written as 2g into x. Now we substitute it here. So total energy at B will be equal to half mvb square plus mg into h minus x. This is what it was. We'll substitute. So total energy at B will be equal to half m. What is Vb? That is 2g x. plus mg into, see, if you multiply mgh minus mg into x. So 2 will get cancelled. So total energy at point B will be mg into x plus mg into h minus mg into x. So plus mgx and minus mgx gets cancelled out. So remaining will be total energy at B is equal to mg into h. Done. Now we'll talk about total energy at C. So total energy at C will be equal to total kinetic energy at C plus potential energy at C. Potential energy at C is 0, as we have mentioned here, but kinetic energy will be there. So what will be kinetic energy? Total energy at C is equal to half mvc square. So let us consider again the final point as C, initial point as A is equal to 2g into distance from initial to final, from here to here, that is h, mg into 2g into h. But V is 0, therefore Vc square is equal to 2g h. We'll substitute it here. Total energy at C is equal to half m into 2g h, right? 2 and 2 gets cancelled, so remaining total energy at C will be mgh. So therefore we can say that total energy at A is equal to total energy at B is equal to total energy at C, and the energy remained constant at every single point. Okay, now if they ask about a graph, right, so what happens from 0, kinetic energy will become maximum, it will increase kinetic energy. What happens to potential energy? Potential energy will decrease from maximum to 0, this is potential energy, but total energy will remain constant. See, total energy will be constant always, total energy will always be constant. Okay, next, application of principle of conservation of energy. This is the application. Simple pendulum. In simple pendulum we have 2 points, one is mean position, another one is extreme position. We have 2 extreme positions, that is one positive extreme and negative extreme. So what happens as soon as we take this bob and leave it, so it goes from mean to extreme, again from mean to extreme. Okay, while it reaches the extreme position, it stops. So if it stops, what happens? There will be no speed, there is no kinetic energy. But if this is the reference point, it raised above the reference point, it means some height above the reference point, so there is some potential energy. So at extreme position there is no kinetic energy but maximum potential energy. At extreme position kinetic energy is 0 but potential energy is maximum. But while coming back to mean position, this is the reference point, right? So at mean position there is no potential energy, but while coming back there will be maximum kinetic energy because of maximum speed. So while you sit in any swing, you can easily understand that while going up there will be less speed, while coming back down again the speed will increases, right? So kinetic energy will be maximum and potential energy will be minimum, that is nothing but 0. But during the complete motion, energy continuously transforms between kinetic to potential. It will be changing, right? Sometimes kinetic, sometimes potential, sometimes kinetic, sometimes potential, but total energy will be always constant. Total energy will be always constant. Okay, next we'll solve some questions. A body of mass 10 kg is kept at a height of 5 meter. Mass is how much? 10 kg and height is 5 meter. It is allowed to fall and reach the ground. Okay, what is the total mechanical energy possessed by the body? See, this is the body, it is allowed to fall from height h. So at this point the total, there will be only potential energy, right? So total energy is nothing but potential energy at A, I can say, at maximum point. Yeah. So total energy is nothing but mg into distance is h. So total energy will be equal to m is how much? 10 kg, g is 10, height is 5 meter. So total energy will be 500 joule. Understood? Okay. Next, what is the kinetic energy possessed by the body just before hitting the ground? It means that at this position there is no potential energy, but there is kinetic energy. So you can say that this total potential energy got converted to kinetic energy. You can say that kinetic energy at C is nothing but potential energy at A that got converted. So kinetic energy at C is also equal to 500 joule. Understood? Easy. Let's go for the next question. The figure below shows a simple pendulum of mass 200 gram. It is displaced from a mean position A to the extreme position B. Okay. The potential energy at position A is 0. At position B, the pendulum is raised by 5 meters. Where are the questions? Haven't given. Let me give you some questions. You solve this as a homework or comment it. Okay. First question is find potential energy at B. Second question is find find total energy at C. And third will be find speed at A. Find speed at A. Okay, do it and comment down the answer. Next, a ball of mass m is dropped freely from point A. It is given that AB is equal to BC is equal to CD is equal to H. The acceleration due to gravity at the point at the given place is G. Then what will be its potential energy at point A? Simple. At point A, potential energy at point A will be mg into height of A. So it will be mg into height of A is h plus h plus h. That is nothing but 3h. Therefore, potential energy at point A is 3mgh. Okay. Next, kinetic energy at point C. At point C is somewhere in between, not at the lowest point. So we can say that kinetic energy at C will be equal to A. We can't say that. So kinetic energy at C we need to calculate. We know that total energy at C is equal to potential energy at C plus kinetic energy at C. So what will be total energy at C? Total energy at C is nothing but potential energy at A, matlab highest point, because there is no kinetic energy at highest point. So that is nothing but 3mgh is equal to, what will be the potential energy at C? mg into height h, mgh plus kinetic energy at C. If this comes here, kinetic energy at C is equal to 3mgh minus mgh. So kinetic energy at C is 2mgh. It will be 2mgh. Done? Okay. Next, the last question of this chapter. Two students are conducting experiments with two identical simple pendulums. Each bob is of mass 100 gram and is raised to 5 meters above the mean position. Okay, 5 meters above the mean position. Okay. The graph depicting the relationship between distance and velocities in the diagram. This is the velocity of student 1 and this is the velocity of student 2. It is 10 and 8. Demonstrate using mathematical calculation that the path followed by the student 1 is devoid of friction. Devoid of friction means there is no friction. It means that the total potential energy gets converted to kinetic energy. Kinetic and potential should be same for student 1. We have to prove. But for student 2, we'll see what happens. So if we solve for student 1, potential energy will be equal to mg into h. So mass is 100 gram, 100 by 1000 into g is 10 and height was 5 meter, right? So 0, 0, 0, 0, 0, 0 gets cancelled. So u is equal to 5 joule. Potential energy was 5 joule. So let us see kinetic energy. Kinetic energy is half mv square. So kinetic energy is half, m is 100 by 1000, v was 10, right? First one is 10, next one is 8. So 10 square means 100. So 1, 2 and 3 zeros, 1, 2 and 3 zeros gets cancelled. 10 by 2 is 5. Kinetic energy is also equal to 5 joule. Therefore, we can say that potential energy is equal to kinetic energy for student 1. And it proves that for student 1, there is no friction present. Student 1 is devoid of friction. The path followed by student 1 will be devoid of friction. So let us solve for student 2. Student 2. For student 2, potential energy will be same for both of them. Okay. But kinetic energy will be different. Kinetic energy is half m v2 square. So kinetic energy is nothing but half, m is 100 by 1000 into V was 8, right? 8 8s are 64. So 1 2 1 2 zeros get cancelled. 2 1s are 2. 2 into 32 will be 64. So kinetic energy will be equal to 32 by 10. That is nothing but 3.2 joule. This is the kinetic energy of student 2. But potential energy is 5. So where is the rest of the energy? It is lost in the form of heat. That is nothing but how much? 1.8 joule of energy is lost due to friction. Okay. So therefore we can say that U is equal to kinetic energy plus lost energy. Total energy, potential energy got converted to kinetic plus some lost energy. So what is the second question they are asking? Does the situation involving student 2 violate the law of conservation of energy? No, it does not violate, because here total energy will be 5. Here also 3.2 plus 1.8 is 5. So energy is neither created nor destroyed. So it is not violated here. Okay, done. So this was the last part of this chapter. So we'll meet in the next chapter, that is machines. Till then, keep studying and keep supporting us, and download the Ezee Notes app. Bye bye.